Hello, everyone. Welcome back. I hope you all had a fantastic summer. I'm Nick Bray from NBA. We're an architecture studio based in Victoria and here in Vancouver on the unceded traditional territories of the Musqueam, Squamish, and Tsleil-Waututh nations. At NBA, our mission is to contribute positively to both society and the environment through our work, which now includes hosting these seminars. The purpose of this seminar series is to offer an overview of timely and relevant topics currently impacting our work and hopefully yours too. We've aimed to make these presentations more practical, focusing on how we can apply the lessons directly to our day-to-day work. And with that, we put together a series of seminars here. Number 8 will be on how to implement artificial intelligence into our workflow with speaker Shun Li from UBC, and that's happening on October 23rd. And then number 9, Brett from our office has been putting together a talk about working with Indigenous communities on architectural projects, speaking with artist Corey Douglas from Modern Formline and Eric Hunter from Sue Projects, and that's on November 18th. And then we're currently working on putting together seminar 10 in December. It's likely to be on insurance and liability in our industry. And then for seminar 11, we hope to be working again with Circularity Engineering in January on a seminar that will potentially look at the conflict between accessibility and security in design. If you're eager to learn more and can't wait for our next seminar, then feel free to sign up for the ZEBEX Decarb Lunch tomorrow, which is on cost-effective strategies to cut embodied carbon. And if you have any suggestions on future topics relating to challenges you are facing in your work, feel free to share them in the chat or send me an email. Also, please use the chat box to ask any questions during the session, and we'll do our best to answer them at the end. But please be aware we had well over 300 people sign up today, so we'll try and get to as many of those questions as we can. For AIBC accreditation points, there will be an online form link to an online form provided about halfway through and again at the end of the session. So please have your AIBC number ready for that form. And thanks very much for filling in the poll at the start. Pretty similar to last time, to be honest with you, about 86% architects. We'd like to see a broader kind of demographic here, but mostly Victoria and Vancouver based here. But again, we'd like to see that wider in the future. Before we get started, I just want to thank everyone involved in organizing these events, especially the speakers who very kindly give up and volunteer their time to educate us. And today we welcome back Elisabeth Baudinaud. Elisabeth is a seasoned leader in policy development and a founder at CarbonWise, a consulting firm focused on low carbon construction solutions. Elisabeth has a deep expertise in energy efficiency and climate-aligned building practices. She works closely with industry partners to bridge the gap between construction realities and climate targets. She also creatively contributes to the industry through her roles with the Carbon Leadership Forum and with the Home Builders Association of Vancouver. With that, I will hand over to you, Elisabeth. Thank you very much.
Thank you, Nick, and thank you for everyone who put together this great Lunch and Learn. I'm very happy to be here, as always, sharing our learnings. And we've got a lot to go through today, but briefly, we are consultants based in the Lower Mainland, but we work kind of across Canada and even in the US with recent US clients on bridging the gap between the policies and what we know needs to happen for climate action, but making it actionable because we have boots on the ground. And we work from design to occupancy, support various types of projects for energy modeling, carbon modeling, research case studies, helping local governments as well engage on those topics and make them more digestible. So today, we have a lot to go through, but I wanted to start with some key definitions on what is embodied carbon, life cycle assessment, some of the key terminology that we hear about. So we'll start with that and then move on to learning about some of the policies that are shaping the industry right now. And then we'll dive into some case studies, real projects that we have worked on, a few of them with Nick and the team. So we'll be able to give you some real insights into those projects. And then we'll end with some recommendations and hopefully very actionable strategies that you can take on and take away and start applying with your projects. So like I said, we'll start with definitions, then move on to policy, case studies, and lessons learned. And there is a first poll up right now about your current knowledge of embodied carbon. You don't mind, I'll pause here just for a quick second for everybody to fill out the poll. We have a couple experts in the room, I see. I hope, Nick, you put your expert, right?
Unfortunately, I can't actually participate, but no, I would not put myself as an expert. I'm learning.
All right. So when we talk about carbon in buildings, we are really talking about two sides of the same coin. So the carbon it takes to build the building and the carbon it takes to run it. And I wanted to start by breaking down the terms that you'll hear about today, because there has been a lot of confusion as well. So on the left side, where this is operational carbon, and so these are the emissions from running the building. So heating, cooling, lighting equipment, it's ongoing. So every year the building is in use, and that's why we call it also recurring emissions. Operational intensity. So this is just the operational carbon divided by the floor area. It tells us per square meter how much carbon a building puts out each year. And it's like miles per gallon, but for emissions. And so this is all quantified through an energy model. Everybody knows about this by now. So the energy models predict the energy use and the operational carbon. And that's the standard tool that we all use today through existing homes, new construction, thanks to the step code, so since 2017. And on the right side, embodied carbon. So also, I like to use the term embodied emissions because carbon could be a little misleading. It's not just carbon we're talking about, it's different types of emissions. And embodied emissions are one-time emissions from the material, and the term embodied comes from embodied in the processes that are used to make and build things. So concrete, steel, insulation, transport, all of that goes into embodied emissions. And most of embodied emissions are baked in before the lights even turn on. Embodied carbon intensity. So this is, again, the embodied carbon divided by the floor area, expressed in kilogram of CO2 per square meter. It's the same idea as operational intensity, and it helps compare buildings of different sizes. And life cycle assessment, or LCA, is how we measure the total picture. So embodied plus operational plus end of life, it's kind of the energy model, but for the carbon side, but it takes into account the whole life cycle carbon. And I put a note here that I hear a lot about is there is some confusion. The zero carbon step code is not the same as embodied carbon and does not regulate embodied carbon. So the zero carbon step code deals with operational performance, but not embodied carbon. So just wanted to get this out of the way before we move on into the focus of today, which is really embodied carbon. So now that we've defined operational and embodied carbon, let's look at how they come together in practice through a life cycle assessment, so our LCA. So the LCA tracks the carbon impact of a building from raw material extraction all the way to its end of life. I like this infographic specifically because it is a loop, and I like to think that we need to close the loop and bring more circular practices into our industry. But it goes from, you see at the bottom left, material extraction A1, all the way down to C4 disposal. So stage A on the left side is production and construction. This is where most embodied emissions come from. Stage B is the use stage. So that's where also the operational carbon is measured. It's one of those stages. And stage C, bottom right, is the end of life. So demolition, deconstruction, what happens after the building has reached its end of life, and what do we do with those materials afterwards? So the key for you as architects and designers is that the decisions that you make early around material, assemblies, detailing have lasting carbon impacts across all of those stages. And that's why we use life cycle assessment, is to quantify those trade-offs. A little bit more on key terms and some of the things that you might have heard already or will hear when we talk about life cycle assessment is to understand the boundaries of the study. So not every LCA covers the same stages. And that's where the terms cradle to gate versus cradle to grave come from. So cradle to gate looks only at what it takes to make a product, from raw material extraction through processing and manufacturing and delivery to the factory gate. That's why the cradle to gate. And it stops before the product is actually installed in the building or used or replaced. And you can think about that as the upfront carbon price tag of the material itself. And that's different from the cradle to grave, which takes it a little further and covers the entire life cycle of the product from extraction all the way to end of life, including construction, use, maintenance, and really what happens after demolition as well. So it's the full story from birth to death. And so for years, the focus has been on operational emissions, about how much energy a building uses once it's occupied and what type of energy source it's using. And that's all very important because those were the majority of the emissions that were coming from buildings before we started to get a handle on those. But the reality is that now operational emissions are going down. In BC specifically, between the energy step code, which regulates how much energy we are using, the zero carbon step code, which regulates which fossil fuels we are using for this energy, and the clean grid we have, the operational emissions from buildings have dropped significantly over the past few years. On the other hand, embodied emissions coming from the materials and processes are becoming a bigger shape of the pie. Why is because we're first building more infrastructure. For example, we are like the site CDAM, that's one of those that is a massive embodied emissions output for electrifying our buildings. And then we also use a lot of high carbon materials like concrete and steel. And we also use heavier assemblies, thicker concrete, or sometimes redundant materials and finishes that increase the embodied carbon without always improving the performance. And that's something that we have looked at a lot because I truly believe there is a balance to be found between having a high performance energy efficient building, but also reducing the embodied carbon at the same time. And so this graph shows kind of the shift as operational emissions tend to go down towards zero, then embodied emissions become a bigger portion. And by 2030, embodied carbon will often represent the majority of a new building's carbon footprint. So for your work, this means that the biggest carbon lever isn't just energy efficiency anymore. It's also the materials you choose and how you put them together. So again, some differences between embodied and operational emissions. On the left are the top 3 sources of operational emissions. And historically, these came from fossil fuel space heating, hot water, and cooking. But with electrification, efficient systems, and the clean grid that we have in BC, those are essentially a solved problem for new construction. Codes and technology are pushing operational emissions down really fast. And on the right, we have embodied emissions. And usually the top three culprits are concrete, steel, and petroleum-based materials. And unlike operational emissions, embodied emissions are not addressed currently by the STEP code or any energy performance rules. So here is the shift. Operational emissions are on the way down, but embodied emissions is rising as the biggest challenge. And that's where architects have the most influence through design and material choices. And this is also why policy is starting to catch up. So just like energy codes and how they reshaped how we were thinking about operational performance, new rules are emerging to guide how we deal with embodied emissions. Which leads us to the next section on policy. So I'll start broader at the federal level, and then we'll narrow it down to what's happening locally in BC. So at the federal level, Canada has started to put real requirements in place for embodied carbon. And these are beginning with some federal procurement and construction projects. So the standard on embodied carbon in construction, for example, since 2022, has required new buildings to consider embodied carbon. And as of September 1st this year, projects must demonstrate 30% reduction compared to a baseline. So that's a significant target. And it forces teams to rethink materials and design choices. And it applies to projects valued at $10 million or more. And those ones that use a lot of concrete. And so that started back in 2022. And in addition to that, since 2023, the standard on disclosure of GHGs, so that's also large federal procurements that require suppliers to be transparent about their greenhouse gas emissions and to set reduction targets. So in plain terms, if you want to bid on a project worth more than 25 million, you have to show your carbon footprint and commit to reducing it. And then looking further ahead, the National Building Code is expected to introduce performance-based embodied carbon metrics around at the 2030 cycle. So this means that embodied carbon will be treated the same way as energy performance, not just voluntary, but code-driven. So at the federal level, the direction is clear. There is disclosure first with reporting requirements, and then eventually reduction requirements, and eventually integration into the building codes. So if you're working on any federal or public projects, these rules already apply and might apply to you. And for anybody else, this is a bit of a preview of what's coming down the pipeline for us all. At the local level, so municipalities across BC are also moving quickly on embodied carbon, even though there is no clear mandate from the province at this point, not the way the STEP code was set up. Some municipalities are taking the lead. And here you'll see a snapshot of some of the larger, smaller municipalities that are starting to introduce requirements. So some are already in place and many more are in development. And the key takeaway here is that, and we can speak about the city of Vancouver specifically, but it's not just Vancouver anymore. So from UBC to Richmond, Squamish, Nelson, Victoria, embodied carbon is showing in either bylaws, rezoning requirements, and climate plans. And again, always thinking about disclosure, reporting first, and then reduction requirements will follow. So it's just very similar to what we saw with operational energy. A quick note on the city of Vancouver. Because of having their own building by law, City of Vancouver has set some targets that are not, so reporting targets and then not exceeding a very broad target for now, and then reducing to 10% reduction coming up, not yet implemented, but there is a requirement to have an LCA done at rezoning and building permit. And I'm sure a lot of you have already gone through that process. And more requirements will follow later. But that's kind of what is coming up in BC, and a lot of local governments are looking at what the City of Vancouver is doing. In the work that we do, we like consistency, of course. Some of the lessons learned from the step codes have been that, having a reporting template that works across municipalities, having even just a process that works across municipalities, because we all work in different areas, is something that they are all considering and looking at. And if you've had experience with one of those municipalities and want to talk about it, I'm also very happy to discuss what is coming up as well. I went very fast over the policy side. We are working on a project to discuss and work on an embodied carbon policy that could work in BC for local governments as well. So supporting this work, we have a poll, and I'd love if you could, here it is, answer those two questions that are coming up here on your screen. The first one is there anything you would want to see in a municipal or provincial framework that would make you say, finally, this is the kind of regulation I want to work with? Free answer here. You can write whatever you want, and feedback is appreciated. And then the second question is, what is the biggest barrier for you in addressing embodied carbon in your projects? So either knowledge education, so if you feel like you just don't know enough, developers or client buy-in, so that clients don't see embodied carbon as a priority or reluctant to pay for additional services. Cost implications and timelines, so perception that low carbon materials or designs increase project costs, not enough project budget to cover the consultant work, policy uncertainty and limited benchmarks or targets. So this is if you find it hard to evaluate what's good enough without agreed standards or without clear requirements or incentives. And the last option you have there, integration in design process and supply chain readiness. So either contractors or suppliers aren't familiar with low carbon options, or making the specs harder to enforce, or if you are also unsure how to bring an LCA consultant in without disrupting the workflow, for example. I'll give you a second to go through that. All right, let's keep going. Thank you for those of you who filled up the polls, really appreciate it. As we all work into integrating embodied carbon in our workflows. Now we're moving on to some case studies. So from very different types of projects that we have worked on, part 9 and part 3, and we want to highlight some of the key strategies that are doable today that we implemented on those projects, and really want to stress that embodied carbon doesn't have to be an extra layer of complexity. If anything, really, I'm a strong believer that reducing embodied carbon is an opportunity to be smarter about how we design and use our materials, and about closing that loop again. Like, I always think about more of a reuse term, and like strategy number 1 is always reusing, because if we reuse any material, we don't have to make it from scratch, so we are saving on those emissions right away. So the first project here, and I'll let Nick speak about this as well. We were very lucky to be working on this one together. It's a 2-unit multi-generational home in Abbotsford, well under construction now, about to be finished in October, November. We are hoping to do a site tour coming this fall, so stay tuned for that. Where the homeowners reached out and wanted to reduce their carbon footprint. So after going through the energy performance, where they right away agreed on, let's do the best we can today, which is for us step 5 and EL4, so an all-electric design. Then we looked at, well, what do we do next? And we looked at some material swaps, but also reuse. And at the time, the process is important, and that's something that you'll hear me talk a lot about, is that integrated process. Because when we first met, obviously there are strategies that we have in mind as consultants, but that don't always work for all projects, right? And so bringing that up front and having the discussion with Nick and the team on what is doable and how we can approach those was really key to the success of this project. And maybe Nick, I'll stop here. We won the Embodied Carbon Award for this project. It has an embodied carbon intensity of 118, and that's full cradle to grave. And on many fronts, that was a real success project for us. Nick, I'll let you give your experience on the project from your side of things.
Yeah, we certainly learned a lot, and what's great about this actually is that we've already been implementing everything we've learned from this project, or a lot of what we learned from this project, into the larger scale projects that we typically do in our office. But we really had to rethink everything. Like we've all been focused on energy efficiency for so long, and the embodied carbon component now of whole life carbon really turns things on its head somewhat. So we had to rethink all our assemblies, our typical assemblies, all the materials and products we were using. So yeah, big learning experience. I mean, we could talk all day long. We've got a lecture on this building alone that we could do, but just in terms of the big hitters in relation to embodied carbon, obviously changing up the insulation is a big one. So our exterior walls, we switched from a sort of a typical kind of Roxol type assembly to using blown-in cellulose insulation, which had a big impact on reducing the embodied carbon. We also used hemp bat insulation for the acoustic insulation within the building. Using reclaimed materials. So the previous house on this site burnt down, but we were able to so part of it burnt down, let's say that. So we're able to deconstruct what remained of the building and save a lot of the materials, including a lot of the studs, which we use for back framing. So yeah, there's obviously embodied carbon savings there, but also a lot of cost savings there of not having to buy all that new timber. We could just reuse what we already had on site. Cladding, the wood cladding that we're showing there, that's all reclaimed. That was an interesting story. That actually came from a forest that burnt down in a forest fire. So it's all the leftover wood within that burnt through forest. So rather than just churn it up and grind it up, we were able to save some of that and reuse it as cladding. A lot of the landscaping we reused, pavers, retaining blocks, all sorts from the landscaping, a lot of the concrete driveways, all that side of things. But the big one for this particular project, and you can't do this on every project, but the big one was we didn't dig up the existing slab of the old house. We saved that slab and built on top of it, which again has both cost and embodied carbon savings for the project. I think a big part of, especially the cost part of this equation, when it comes to embodied carbon, is really just thinking, well, the initial step, just thinking like how much impact is the embodied carbon of each of these products. So if you're weighing up two products or two materials that have the same cost or similar performance, obviously choose the one with the lower embodied carbon. It's not rocket science. And just that approach was made a huge impact. But the one I think it's the most interesting, or the one I like to talk about the most, is the roof, because we did also look at steel roof, we looked at asphalt shingle, and we actually ended up installing a product called EnviroShake, which is a composite roof tile. Looks kind of like a slate roof, but it's largely recycled content. But it does cost more, significantly, maybe 1.5 times as much actually as an asphalt roof. It's quite a big cost increase, but the longevity of that product it's night and day. It's got a 50-year warranty on it. So, compared to sort of asphalt roofs, you might even be replacing that in 15, 20 years. This product has a 50-year warranty on it. So if you actually look at the cost of that product over the life of the building, yeah, the cost wise, it's actually a reduction, more upfront, savings later on, but obviously a huge embodied carbon saving when compared to the alternatives of especially asphalt shingle. Don't know if there's anything more you want to speak to on this project. No, you're good.
No, that was great, Nick.
So we actually went on and took a lot of those learnings and put them into part of this project. But the first part of this project here, so this is a social housing site with a number of apartment buildings on it in Vancouver. And the first part of this project was to review the four older buildings on that site. And you can see one of them on this slide. And of those four, two of them we found through that condition report to be savable. Like we could just do a renovation on those, whereas two we found were beyond saving. There was little to be saved from them. We'd have to knock them down and deconstruct them and rebuild. So the first two, the two retrofits we've already completed, and they involved stripping off the existing cladding, replacing the windows, adding a new air barrier, adding additional exterior insulation all around it, and obviously new cladding everywhere. And just on the envelope side, I think obviously there's a huge increase in comfort there for the residents, but also we've massively increased the longevity of that building because it's effectively like a new building now. So it's all sealed and weather tight and new cladding. So huge increases in longevity. And then on the mechanical side, it's now all electric. It went from gas to being all electric. We've got a centralized heat pump hot water system in each building. And every unit gets like an Innova heat pump, heating, cooling system. So yeah, I mean, obviously the just the costs, the financial costs, and embodied carbon savings of retrofitting versus new build are very, very significant. But unfortunately, on the next slide, we haven't started this project, still in permitting. So this one is 24. I think it's actually gone up now. Actually, we just increased the size of it. New build social housing building on the same site. And as I said, we took a lot of what we learned on the Phoenix project and used a lot of those same assemblies, tweaked them slightly, made them, yeah, they're not as quite high performing on the energy efficiency side as they were on Phoenix, but similar idea. I would say though the big saving here, both in terms of cost and in terms of embodied carbon, was removing any sort of basement on this project. So there's no basement parking, there's no basement space whatsoever. So we can save all that concrete in relation to that. I know you can't do that on every project, but if there's any option to or route to reduce the amount of concrete, you're automatically going to have a big saving. Yeah, so the parking for this site was at grade, and then we've got all the bike parking on the ground floor of this building. So we feel that we're still waiting for the final numbers to come in, but we feel like the difference in financial cost for this project versus a typical project of its kind that meets the same energy performance is negligible. There's very little difference in terms of cost.
Thank you, Nick. And then to give you a bit of a variety of projects, we also worked on a City of Vancouver tower. So as part of a rezoning process here and building permit. So we put together, and there's more details into an actual case study that was published by the Carbon Leadership Forum. if you want to look at the details of that. But really here we wanted to showcase some cost-effective strategies to reduce embodied carbon. So we hired a cost consultant as well, an estimator, to go through some of those changes. And we were able to achieve 334 kilograms of CO2 per square meter, which is really 12% reduction from a baseline. So we were looking at, just interested in researching how can we meet the future City of Vancouver code, which will be requiring 10% reduction in these projects, achieve 12% reduction with some cost savings. And so some of the strategies that were reduction of parking levels went from 3 to 1.5 underground, and then replace the curtain wall system with the steel stud wall. So that was an interesting thing to go through, which is very linked to what we're going to talk about next, about a systems approach. And on this one, well, I'll dive a little bit deeper into this fire hall case study that we worked on, comparing two designs. So the complexity of always, doing a baseline and comparing your building, your actual building, to a baseline building, is that we often, and that's what has been the case with the projects with Nick, is by design, the building is already low embodied carbon, because they have already implemented those strategies. So is how do we show what would have been otherwise, right? And so this project, the fire hall, was a great example where we were given two designs. We were given what they called mass timber, which ended up being a hybrid design with concrete, steel, light timber, and a CLT floor, and a concrete tilt-up design. And basically what happened there is, originally the intent was to go for the timber design, and then through engagement with the community and some pushbacks from the local community, they decided to go for the concrete. So it was interesting because costs of course came as one of those issues, but then we were looking at, what does that really mean? And that's after the building has been built. So we were able to look at and trying to understand where that came from and where the cost savings came from or not. And then what that meant. And so when we were given, and all of you will see from the pictures here, is like the designs were not looking the same. So first of all, the timber design had a more complex footprint, which implied more connections and details. The hose tower was actually larger, had more complex design. On the timber one, roofs also were different. So for two designs that were supposed to be the same, there were quite significant variations already. So the concrete design had primarily steel truss with a steel deck, and the timber design used a combo of exposed GLT, dimensional lumber, and structural steel. And so both buildings used exterior insulation, and they were also, it looked to us that the timber design had obviously concrete and steel elements to it. So it was a little bit more ad hoc than what we would have expected from a full mass timber design. So the structure also was slightly different. And so what we did is we did two LCAs, and from this we really could compare those two buildings, but eventually the limitations are that they were not the exact same 100% same buildings. So what this table shows is that the results can swing a lot depending on how you set the scope and what assumptions are built in. So not only the designs had differences, but also when we looked at different stages of the LCA and whether or not we include biogenic carbon, which is a topic for a whole other hour that we don't have today, but lots of experts on the call that can answer questions around that as well. Is that what I want you to take away is that depending on the boundary of the study, the results can look very different. So A to C includes production through end of life, and A to D adds any potential benefits from recycling and reuse. And when you start adding biogenic carbon storage into the mix, the numbers change even more. And so just want to say that it matters when we look at LCAs and when we compare projects. And our goal is always to make sure that we are comparing apples to apples, not apples to oranges. But that's especially important when we are comparing one design option to another. And the results, you have the percentages there. If you're also more curious about the nerdy details, we are going to be publishing very soon the full, I think it's 20 plus pages report. So you can reach out to me or subscribe to our newsletter, because we'll be releasing it through that. But the interpretations depend heavily on the methodology. And so life cycle assessment is a powerful tool, but it's also very sensitive and needs to be applied to each project for the goal of the project and what we are trying to get. So out of this comparison, some things really stood out for us is that there were some key design and delivery differences between the two buildings. So we were able to really, having the plans and having structural plans for both, we were able to really list what that was. So first, the design maturity. So one of the buildings, the concrete ended up being built, but the timber not. So the timber plans were still early stage, and the concrete design had already gone through some cost cutting and refinement. So that affected obviously both emissions and price. The concrete design was integrated and efficient. So tilted panels combined structure, envelope, insulation, finish in one system. So that was reducing trades and simplifying construction and therefore reducing costs there. The timber design was a bit more fragmented. So it relied on multiple trades on site, from framing to cladding, insulation, fire barriers. And there was a unique wood steel connections that also added complexity. And coordination gaps also added costs. So more trades on site mean maybe higher costs, just like more complicated schedules, and also more risks for the timber option in this case, which I really want to stress that this was not a mass timber design, even though when we were approached, we were asked to compare a mass timber design versus a concrete design. It happened that it was more of a hybrid system, which is where we don't see those efficiencies, right? So it's important to make the distinction there. And so a lot of lessons learned from this project and all of the other LCs that we have done so far. And I want to move on to the key takeaways and things that you can take on and use for your next projects. But when we compare designs, it's very tempting to look for a simple answer. Like timber is always better or concrete is always worse. But really what we found is more nuanced than that. So number one, circularity matters. Think about that loop again. The ability to look at taking buildings apart and reusing materials can completely change the carbon story. So a material that looks bad at first can actually look much better if it's designed for reuse or lasts longer. And that's the case for the roof on the Phoenix house, for example. So in this case, where it had a lot of recycled content in it, but when we looked at a steel roof versus the asphalt roof, and conversation we've had multiple times on the upfront carbon, the steel roof looks much higher than the asphalt. And so if you only look at this and you only look at carbon, you'll be thinking, well, let's just go with the asphalt. But the asphalt needs to be replaced more times. So at the end of the day, is it better or worse? So all of those things are things that we consider when we do the LCA. And biogenic carbon, of course, is another good example. So timber and mass timber store carbon, but that storage only matters if we protect it over in the long term. So if a building is demolished and the wood is burned, then that advantage may disappear, right? So important, again, thinking about the loop. And on costs, it's not as simple as saying mass timber is always more expensive, which we've heard. But what we saw in the design of the fire hall is that the stage of design and the level of integration makes the biggest difference. So, which leads to the last really takeaway is material alone is not a strategy. So that might be the most important, is picking a material isn't the same as having a strategy for a system. So the outcomes that we care about, carbon, cost, constructability, depend on design integration. and trades coordination and potential prefabrication and circular thinking. So just swapping one material for another just won't get us there. And maybe Nick, do you want to speak about the high performance costs versus embodied carbon costs?
Yeah, this could potentially get us in trouble, but this has never stopped me before. Um, yeah, you talked about BC, and we've got a very different scenario here with our electrical grid being so low carbon, with the hydro being such a big factor here. So this really, I guess what I'm about to say really only applies, well, it applies specifically to BC. It would be a different story, for example, in Alberta. And also it applies specifically to all electric buildings. Because obviously, when we're trying to get away from fossil burning buildings, scenarios, or grids, so we've got a very different situation here in BC. Um, so energy efficiency is important. We've been very much focused on that for many years now, and I think we need to maybe take a little step back and reevaluate, what matters here now, especially in BC. And as you said, Elizabeth, embodied carbon is, obviously is something where we need to be showing our focus now. Now, the reality is, and this is where I'm going to upset some people. The reality is that producing or designing more energy efficient buildings costs money. There's no getting away from a high performance window costing more than a low performance window, or a higher efficiency mechanical system costing more, or adding additional insulation is going to add cost. I mean, there's no getting away from that. Now, what we've learnt, and hopefully we'll have the numbers soon to back this up, but what we've learnt that is that when looking at whole life carbon and taking into consideration not just energy efficiency and lowering operational carbon, but also taking into consideration embodied carbon, is that for the same, for when you take it into account the financial costs of this, really trying to come up with those same carbon savings through embodied carbon, we found to be less expensive than doing it through increasing energy efficiency. Because as I said, yeah, I mean, Elizabeth, you spoke about it's not as easy as just looking at materials and products, but there are some simple wins really, like in terms of just some material selections. Some things are going to cost more, like we talked about using cellulose insulation versus say rock soil or foam. There's going to be some savings like reducing concrete that we talked about as an example, and then there's going to be some just alternatives that have very little cost difference where we're choosing one option over another that have the same cost or same performance, but have a different embodied carbon rating. So what we need to start moving towards, in my opinion, is balancing those targets and relating to energy efficiency with introducing new targets relating to embodied carbon. I'm not saying forget about energy efficiency, I just want to make that clear, but balancing those targets, I think, is the way forward. And I think if we do that, we're going to see a bigger positive impact when it comes to the climate crisis here in BC. And I think we're going to see a bigger impact when it comes to the housing crisis as well, because I think we'll find cost savings by that balancing process. Um, yeah, I don't know how much trouble I'm going to get by the diehards by saying that, but
Balance is the key. There
balance
is
is the
no
key.
there is no silver bullet. Which is a good segue into the last few slides here on recommendations. So apologies, it's a lot of writing on the slides, but really want to stress that we need to design for system integration more than the material swap. And that means starting early and coordinating with different consultants, aligning what structure envelope mechanical systems from the beginning to avoid the redesign and added costs, and also keep assemblies simple. fewer layers reduces, of course, trades, site labor, and lower risks and lower embodied carbon. So it's usually we find a win-win-win. If doing prefab, which I think from a lot of points is a great strategy, then engaging suppliers and trades upfront is really critical. We've heard this from Kalishnikov on this project with the Nelson study, where they came in and literally told us, well, they didn't do they weren't part of that project, but they showed us how if they are integrated early, then there is all a scheduling that is like so optimized that makes a lot of sense. And so they have concerns about and we are working with them on another single family home where they have concerns about the roof line, for example. And so then on the prefab side, they bring those concerns early, and us on the energy modeling side and the carbon side, we're looking at, well, how can we work this out together to make these systems work harder, which is the next point, is using materials that can serve multiple functions, that can be structure and finishes, for example. And also think ahead for the end of life. So one thing that we often don't worry about too much, because we are thinking, well, this is 60 or 100 years down the road. Well, there are buildings that are already here right now, for example. So if you're still doing this on your projects, please stop using spray foam on wood, for example. That's one example where, like, if you're still doing this, stop right now, because this is a perfect example of how wood cannot be reused if it has spray foam on it. So this is how we start thinking about what may happen in the future, but we have existing buildings now that can be deconstructed, that can be we can recover some of those materials. So thinking about that end of life and what that is, whatever stage you're at, is also very critical. Recommendation number 2, leverage prefabrication. It simplifies construction, shorten timelines, and amplifies the carbon savings. It's a very efficient process if it is, again, combining systems, planned early, and working locally. I think this is something that we, with what's happening at the south of the border now, that we are thinking a lot more about, but we have the resources in Canada, we have the suppliers, and we have companies that can provide this much needed housing. So it's about thinking about how can we engage them early, how can we engage local suppliers, partners, and make projects just stronger from the get-go. Recommendation number 3, engage the local supply chain early. And we have a law, and we don't need to get into all of those details. There is Woodrise happening this week, and a lot of the people attending Woodrise, for example, are potential partners for projects where there is regional sourcing and just technologies and or just materials that we have right here that can be used on those projects. And I'll end with commit to mass timber early. So on the case study for the fire hall, what we really saw was that it was not a full mass timber building. And so therefore, the efficiencies of mass timber could not be integrated into that design. So there are a lot of opportunities to eliminate materials and drywall, and a lot of just optimizing assemblies and assembly, like the constructability as well on mass timber, that need to be, if you want to take full advantage of mass timber, you got to start with thinking mass timber from the design. And we've seen, and there are a few projects in BC that are also success stories of showing a lot of cost savings related to full mass timber designs when they are done properly. So I'll end with that, and just say that the polls that we have posted, and there's the next one up here, are really helping us shape what potential embodied carbon policy could look like. So thank you for taking the time to fill those out. So the last one here, is which resources would make it easier to address embodied carbon in your practice? We really want to hear from you. It could be cost carbon comparison, local materials database. So that's, if you need more information on regional suppliers, that would improve confidence in specs, or client communication materials. So any slide decks, briefing notes, any fact sheets that could explain the value to clients. Early design guidance, so access to an LCA expert. So either, if you need something like rule of thumb guidance, or someone to bring in at concept or DD stage that can provide early on and ongoing design. Policy clarity, or training and education, either short courses, webinars, or workshops. Just let us know what resources would make it easier for you. I'll stop right here. We have a few minutes up for questions. And
Yeah, well, firstly, thank you very much, Elizabeth. Really, obviously, really appreciate you taking your time to speak to us. Yeah, it's obviously a really important subject, and thank you so much. Before we get into the questions, I just want to highlight that the AIBC link to the form is in the chat box. Please feel free to click that link and enter your number in yourself. We're not going to do it for you. Also, in a minute, we're going to just do a quick poll to help us. There are some direct costs whilst we're all, my firm and the speakers are volunteering their time for free. And we'll continue doing that to set up these seminars. There are some direct costs in doing it, and I think we're going to put a poll up in a second, just to see whether you're willing to donate a smaller nominal amount of money to attend these seminars, whether you'd still attend. That money will go to covering some of those costs, and then the rest will go to charity, most likely Habitat for Humanity. So that poll's going up now. Regarding questions, again, thanks so much, Elizabeth. Oh, sorry, I should thank the team at NBA as well. Shannon, Ori, Ella, that have been working on putting this together. So thank you. Yeah, questions. So there was a few there, Elizabeth. Firstly, I was wondering if you could speak to some of the results of relating to the challenges, the poll relating to the challenges that we face, and the highest number there, that the biggest concern was getting developer buy-in. I know from our experience, and I probably shouldn't be sharing this, but from our experience, it's we just do it anyway, as long as there's no cost impact. We don't get developer buy-in. We just go ahead and do it anyway. We make decisions that are positive on the in terms of embodied carbon, and just incorporate them into our work. But Elizabeth, maybe you could talk a little bit to the results of that poll.
Yeah, I think this is a topic for sure. And maybe we'll just need to do another one of those with developers. But I do think that you are approaching this with the right mindset, Nick, and that's why it's been such a pleasure working with you and your team. Is that it doesn't have to cost more, and I think there is a perception that it can add complexity and another layer. Like it's like, oh, we had energy efficiency, and now there is embodied carbon, right? But it all ties together, and so I find like what you spoke about finding the right balance and making and having those conversations early. I think with bringing on the consultants and the teams really early on, and just having a very quick discussion. It doesn't have to be anything fancy, right? It's just like having coffee around the table. I think, in my opinion, really can make successful projects in terms of embodied carbon and costs, and is always better for developers and builders to be engaged early on anyway in those conversations as well. So key to success, integrated approach.
Absolutely. And we had a question earlier on, actually. It was more about when we were showing the case studies about the tower, and whether the reduction in embodied carbon was again suggesting that was it from reducing the parkade, or was it through a larger scale of kind of integrated approaches?
So on this one, we looked at so we did a cascading effect for different strategies. And yes, the parking ended up, because of the concrete reduction, ended up reducing embodied carbon the most for this one. But the details are available. We can share the link as well. Where we have the table showing the percent, I can't remember off the top of my head the percent reduction linked to specifically the parking, but I do remember that we had them in cascading effect, and then the total was brought up to down to 12% reduction.
Fantastic. We are dead on 1 hour now, so I don't know if you want to, if there's anything else you want to add, Elizabeth, but you know, timing could not be better on this. Is it any further comments?
If there's any last minute questions, I'm happy to stay on a little bit more as well. And feel free to connect as well. Send me an email if you have any questions or any follow-ups, or want to discuss any of the things that we talked about today.
Brilliant. Thank you so much. Yeah, hopefully we'll see everyone here at the next seminar.